Good afternoon, dear students. Let me first introduce myself. My name is Vladislav Gennadievich. I'm an assistant at Applied Mathematics Department, and you will have practices with me. Today our topic is determinants. And what do you remember from lectures about determinants and matrices? By the way, don't be afraid of making mistakes. So if you are not sure about the meaning, so if you afraid that you can make mistake in the answer, don't be afraid. You are just studying. So who wants to answer?
Can I please?
Yeah.
Matrices is a couple. Unfortunately, I don't know. Можна українською? Чи тільки англійською?
Okay,
Забув
you can
слово.
try. Of course, it would be better if English, but okay.
Матриця – це таблиця показників системи лінійних рівнянь.
Well, actually, that's a possible answer, but let's generalize it. So let me share my screen, and I will paint a little bit. Oh, that's too thick.
Matrices is, can I answer your question?
Yeah, you can do it.
Matrices is like portrait rectangular array of some numbers. We can show it as maybe table.
Yeah, sure. Actually, that's a table which looks like that. So it has a dimension n by m. Okay, let me write it better. So we.
Question.
By the way, I will end and then you ask. So n rows and m columns. Yeah, so now you can ask a question.
Do we need to check in anywhere?
If I'm not mistaken, the system will record you automatically. If not, I will do it for you because actually I see everyone who is present, so don't worry about that. Okay, so yeah, matrix is a table actually, and it is definitely can be used for solving linear equations, but we'll talk about it on next practices, not today. Today we'll talk about quadratic matrix, so which has dimension n by n, so the same number of columns, the same number of rows. Don't forget that first index is a row and the second is column. So don't confuse them. Yeah, in the start, it's possible situation. Oh, no, it was a mistake. So be attentive and check myself as well, because here I had to write 1. And here is an incorrect order. So it's a square matrix, and in square matrices we can define main diagonal and the secondary diagonal. So main is for number, so for elements with the same row and column index. So from the top left corner to bottom right corner, and the secondary diagonal elements from top right corner to bottom left. So actually it's easy to understand if you, so easier to memorize if you had some experience in programming, you definitely know something about that. And how to calculate determinants for matrices. So what about the matrix of dimension 2 by 2? So do you remember the formula, how to calculate it? Who wants to ask? Actually, who haven't asked yet? Answered, sorry. So who wants to answer how to calculate determinant? And actually, how do we write it?
It needs calculate by cross rule.
Yeah, by cross row. So
Firstly,
sorry?
we multiply A11 by 1, A2, 2,
Yeah.
and subtract A21 multiplied by A12.
Yeah, so actually we multiply, so we subtract multiplication of main diagonal, so we subtract multiplication of secondary diagonal elements from the main diagonal. And here is determinant of the second order matrix. And what about the third order? So let me just write in this way.
We should multiply A by 1, 1, A2, 2, A3, 3, plus A2, 1, A3, 2.
Can I answer?
Actually, if your colleague ended,
Oh,
so
I'm sorry.
respect each other.
After I end.
Oh, by the way, you are raising hand. Sorry, I didn't see it. Yeah, so let's see the queue actually. So who was the first? Yevgen or Alexander?
Yevgen.
Okay.
We need just to use Sar's rule. If I'm not mistaken, it's called like that. We need to use these numbers on the main diagonal, then just create some triangles using the two numbers below the main diagonal, and use it with the number on the upper corner. The same we're doing with two numbers. Just A12 and A23, if I see it correctly. and a 3-1.
Okay. Well, actually, I won't write it because it will take a lot of time, but we have a good illustration in our presentation. So, actually, here is the rule for determinants of the second order, and yeah, for the third order, it's a triangle rule, actually, that you said. So these elements with the plus sign, which are the main diagonal, and triangles, which if we can say parallel to it, and analogically with the negative. So I believe that this figure will be more understandable for you. So, okay, let's start with the doing exercises. Let's solve the first one together, and then some of them you will solve in your own. So, exercise 1. Uh, 1A. Let's make it more simple. And as we remember, we just multiply numbers that are on the main diagonal and subtract numbers from the secondary diagonal. So, and the answer is 18. Okay, and the second, let's do in your own. And I will do it as well, and we will just compare our results. Are you ready? If so, just raise your hand. Okay. The first was Mikola, so let's start.
I have 4. I
Uh,
have 4.
4?
4.
Just 4?
Mm,
Are you sure?
do we solve the B variant?
Yeah.
I'm not right. Yeah, I'm sure that is 4, but I can write.
But actually, you are missing something. So who can help?
For AB.
Yeah, so for AB. So don't lose letters. Okay, and let's go with the next examples. They are quite interesting. Currently, lower your hands if you have no questions, and then when you finish, raise. So as I see, Stanislav is ready. So what is the answer?
I got the answer 1.
Yeah, the answer is 1. So it's square of cosinus alpha plus square of sinus alpha. So it's the main trigonometric equality. Yeah, so the answer is right. Okay, let's solve the next. By the way, how are you going to start solving calculating this determinant? So, do you want to simplify it before actually calculate the determinant itself? Any ideas?
We need to rewrite 2 sinus alpha cosinus alpha to sinus 2 alpha.
Yeah, so actually we reduce the power. But don't forget to raise your hand firstly before answering. Okay, so if I'm not mistaken, Artem was the first. So what is your answer?
It's 1.
Yeah, so actually it's 1
Yeah.
as well. But we just had to simplify these expressions. Okay, let's calculate determinants of the third order. So the first one we are going to solve together. So it's quite easy. Actually, it looks like. So 3a. Actually, we will have not a lot of addends here because we have zeros. So what we just do, we just subtract main diagonal, so subtract a secondary diagonal from the main. So because here we have zeros, here are zeros, and the same for negative. And let's just write it in this way, like square. So, and the answer is -2. And let's solve B in your own. So when you finish, just raise your hand and we will compare the result. I was muted, so Mikola was the first, but yeah, let's ask anyone who hasn't answered yet. Okay, Alexandra, your turn.
Yeah, so basically we have in the B we have 4.
Yeah, all right. So 4 with using triangle rule, and now let's solve D. Actually, but with using other rule. So maybe do you remember from the lectures decomposition of determinant row or column? By the way, what do you remember about such things like minor of the element and algebraic complement?
Yes.
So what is it? Actually, if we talk about, for example, this matrix. So,
Mine,
yeah, Daniel answer.
minor is when we delete I row and J column.
So, and what is the minor for this element 2, for example?
4, 2, 0, 1.
And it will be a determinant, actually. So minor of 1, 1 here is such a determinant. Yeah, so actually this answer is correct. And what about algebraic uh, complement? How to calculate it? Actually, it looks like the same, but not really. So we have some difference between it, between such terms. Daniel, you actually answered, but who had? Daria, I haven't heard you yet.
To calculate this, we need to minus 1 in power of 1 plus 1, actually the number of the row and the column of the elements, and we need to multiply it by the minor of this element.
Yeah, so actually here in this power we have indices of the element, and here we'll just write a minor. Okay, and actually how to calculate determinant in other way? We can do it like this. Oh, maybe you can remember it. Why not? So, can you answer? Any ideas? Oh, I just don't see your hands. No hands. So don't be shy, or you just don't remember how to calculate determinant by decomposition, or in other words, just with using algebraic complement. So,
Just don't remember.
anyone more? Oh, okay. So no new people for now. Okay, Mikola, you was the first.
You can multiply all minors in a row.
Well, actually, not. So multiply minors. I understood. What did you mean? So actually not minors, but we. Yeah, let's go like in this way. So this delta means determinant as well. So we multiply not minors. We take this element and multiply it by its algebraic complement. Then take this element and multiply by its algebraic complement. This multiply as well, and then all this composition we just add. So we just have a sum of this composition, and it will be a determinant. So let's solve D. I have not enough space. Let me create a new file. Oh, 2D. Okay. I will write it in details. By the way, how do you think which row or column do you want to use here? This, or this, or just with go with rows? So who else? Actually, it would be better if I hear new people. So let's work together. Okay, Maxim, yeah.
We can use the first row and the first column so that in the minor we will have 0. It will simplify the multiplication process.
You mean first column? But the first
Yes.
first column is this one, and
This one.
first row is this one.
First column is 2, 3, and minus 1.
Oh, no. Row is a horizontal thing. So this is a row. And this is a column.
Yes, but you asked about the column.
Actually, we can go
Actually.
either with the column or with a row. So your propositions, your suggestions. So, okay, Daria, or maybe anyone else. Okay, Daria, you wanted to ask or to answer, or now you don't? Okay. Okay, so Daniel, what about you? I haven't heard you for a long time.
I think
What do
we
you-
need to use 3. It's second row and first column.
So
Uh,
we
Because in the secondary diagonal it will be 0, so we need to calculate on only main diagonal. I think.
well, actually, that's not what I was suggesting, but maybe other ideas.
Can I answer?
Okay, I can't open the queue, but okay, answer. So
Oh, we should use the third row because it contain 0. It
yeah,
will be much more easy.
yeah, just for less calculations. So we just and not only 0. We can go with 0 using the second column, but here -1, 0, 1. Let's make it simpler. So what is the algebraic complement of this element? And by the way, okay, firstly we go with the -1, that is the element, and then -1. So which power?
For
Power
fourth.
4, yeah. And which determinant, minor, actually, do we have here?
-2, 1 in a row.
Yeah.
4, 2 in a second.
Okay, 4, 2. Okay, and actually 0. I won't write the same for 0. It just not really.
It's
It's
just
useless.
minus.
Yeah. So and here, which power?
6,
Yeah, power of 6, and the minor.
2 -2, 3, 4.
Yeah, and it looks actually quite easier that if we took this column or this row or another one. So here it's minus, let's calculate. So -4.
It's 8.
Yeah, -4. Oh, okay, 8, but let's write it in details. So here 1 and so 8 plus 6. So 8 plus 14, and the result is 22. Yeah, so solved it together, and now let's have a break for 5-7 minutes, and then we'll continue. We will solve determinants of the fourth order, but don't be afraid. We have good methods for solving them, for calculating them. Let's continue. Let me share my screen. So actually, these exercises, so this determinants B, C, and E will be a homework. Actually, you will have individual tasks that will be checked, but this just for your practice, because you also will do some tests. And let's calculate. Let's do some exercises with the determinants of the third order. So let's solve the equation. These ones. It looks a little bit complicated, but if you calculate the determinant, it will be easy for you. So let's start solving, and we will compare results.
Should we use
Yeah. Could you repeat your question, please? Actually, do you hear me or not? So could you repeat your questions if you still have it?
I asked you, should we use the composition method or the Saurus method to solve this?
As you want, actually.
Okay.
So Stanislav, are you ready? Yeah.
Yes.
So what is the answer?
I got two answers. It's 1 and -3.
Yeah, actually one answer, but two roots, because it's so it's just a square equation that you know it from the school. Just you in a determinant view. So, and actually, what about inequalities? Let's solve the first one, and then we will go with the fourth order determinants. So, currently doing 4A. Okay, Stanislav is ready. Maybe anyone else who haven't answered yet. So actually, I want to talk with everyone. Okay, so Adrian, and what do you have?
I think that x is bigger than 4.
Well, let's recalculate. Well, actually, for me, x is greater than 2. And what the answer for others? Stanislav or Mikola was
I
ready
have
as well.
similar answer. X is bigger than 4.
Oh, yeah. Okay, so some mistakes in my calculations. But anyway, actually, it's like a usual linear inequality. So I saw that someone had a question, if Evgen, if I'm not mistaken, so raised hand.
No, it's not me.
Oh, not you?
I wanted to ask. I have bigger than -5. It is incorrect, yes.
Actually, yeah. So you need to recalculate it, but it's just a linear inequality. So actually, nothing new for nothing new for you from school. The tasks, exercises 3 and 4b will be your homework. And now we're going to calculate the determinants of the fourth order. So actually, how are you going to calculate them? Any ideas? So just wait, let me hide some spoilers. Yeah, Adrian, your ideas?
By 454 determination how to calculate.
Yeah, how to calculate determinant
Can
4
you
by 4?
can you show me the tasks?
So in
We
this
will.
way?
I think we should use the fourth column because there are simple numbers. We just do the next. We 0 by the minor of this number, then minus -1 multiplied by his minor, then plus 3 by multiplied by his minor, and -1 by multiplying his minor.
Yeah, actually, we can solve it by decomposition of the determinant by a row or the column, but maybe any maybe other variants, other ideas. Daniil, yeah?
I think we can use cofactors.
Now, could you repeat, please?
Algebraics coefficients.
Okay, understood. Yeah.
No.
So, actually, did you have maybe some such examples, some examples on lectures, like we set all elements instead of only one in the row or column, set them zeros, and then just you multiply one coefficient by the algebraic complement. Do you remember it or not? Did you have it? Okay, let's just, for now, let's see an example. So we have such a determinant of the fourth order. So here is a ready example. And what, how do we deal with such determinants? We can reduce reduce the matrix. So like it's a third order. So we set zeros. Okay, let's see this example. So here is our determinant. And then we turn it, we convert it to this way. So here we see only zeros, and here is 1. And we just multiply 1 by its algebraic complement. And how can we get such a determinant? What we actually do? Yeah, Mikola, any suggestions? So do you any ideas, or you just have read the explanation? Anyway, let's listen to you.
Okay, we multiply all in a row and we multiply row and add it to another or column. Doesn't matter. Then when we have all except 1 0, we reduce this determinant.
Yeah, so actually, I need to set this as a 0, this element. We have such property for determinants that they will be equivalent if I multiply one row or column and subtract from the other one. So actually, what we do for -3, I just multiply. So here I multiply 1 by -3 and subtract it from this row. So multiply by 3 and add to the first row. So here is 0, so nothing changes. Actually, nothing changes for the first row. What about the second row? For this column, as I mentioned before, I multiply by 3 and add it. So here, if we multiply 4 by 3, we have 12, and if we add, we have 16. Here we have 6, and add it to 2, and we have 8, and here is 0. For this one, we just add this number to so I just add the fourth row to the second, and I have such numbers. So 4, 0, 6, and 3. And about the third row, the third column, actually nothing changes here, and here I need to multiply by -5 and then add to this row, to this column. So here nothing changes, -1. We multiply 4 by -5, and here we get -20. Nothing changes. Yeah, so here is 0 because we subtract 5. And here we multiply by -5, so -5 minus 10, and we have -14. And we just now multiply this 1 by its algebraic complement. So it has indices 3, 4, so actually -1 here. And we just take, okay, let me paint. So, and we have these elements, so they go here. And this row goes here. And then we can calculate in any way we want. We can either use triangle rule, or we can decompose it. Actually, it depends on metrics. Any questions?
Why are
question.
we using a rectangular table instead of a square table? Because as I know, determinants can be computed only from the elements of the square table.
But it's a square matrix. So 4 element in the row,
Ah,
4 element in the
sorry,
column.
I don't see. Okay.
Yes. So yeah, actually, maybe you got confused because of these
Yeah.
guides. Yeah. So of course we can't calculate. We can't calculate determinants for non-square matrix. Yeah, it's a good comment. Okay, and let me just hide it. So let's calculate this determinant, determinant A. Actually, we have a lot of variants how to reduce. We have good coefficients, but let's go with okay, let's go with this with the first row. Actually, it looks good, and we just will multiply by 1. So let's solve it together. For now, and I will refresh my painting. By the way, do you see it well or not? Maybe should I zoom a little bit?
We see.
We see it well, I think.
Okay.
At least I see.
Okay, I guess it will be better for now. Actually, if we have some time, we will also reduce the determinant to a triangular form. But if not, don't get upset, because we will transform matrices to triangular form when solving linear equations. Okay, so I want to get zeros in this column. Let me just change the color. How to do it? Okay, let's go with this one. Oh, okay. Let's not. I won't do it.
It's not what you need.
Yeah,
Right.
actually, I have no experience in this tool, and actually, I don't like any graphic software. But yeah, I would be grateful if you help me.
It's
Yeah,
right away.
what do you want
Advanced
to do?
color selector.
Okay,
You
where to
just want to
navigate?
select the
In
color?
the right part of your screen.
Yeah, and it is hidden by zoom. Okay, thanks. So let's go
Also,
with
you can just right click to change color.
okay. Yeah, good idea. So these elements will be set as zeros. So, how will I rewrite my matrix? So, a determinant, not matrix. So, let's first write the third column. So here we have 1 and zeros. So I need to get a 0 here. Yeah, and by the way, the first row is not modified. So how to get 0 here? I multiply by -2 the first row, and okay, let me. Yeah, let's multiply by -2 and add it to this row. So what we have here, you can help me actually. Which number have we here in this cell? Yeah. So actually, with the second row, Mikola, help me. Oh, the second row.
Okay. We can take second row and multiply it 3, add it to the first column.
No, actually,
Oh, no, not first column, first row.
Fourth, maybe you mean to first?
Not first. Why first?
So I
And
need
then
to.
we can take 0 in a third column.
Well,
Fourth
actually,
element.
actually, it's not right, but maybe Adrian, maybe you can help. Actually, how we
I have
can.
question.
Question,
We
okay.
can just multiply the second row by -2, or we must to use the another row.
We multiply the first row by -2 and then add it to this row, to the second. So which coefficient do we have in the second row?
-4.
Yeah, -4 here.
2.
Uh,
Or adding
are you sure?
3.
Yeah,
S-
3. And here, actually, nothing changes because of 0. But by the way, we can just put here elements without any changes. Let's go with that. Okay, who will help me with this third row? Stanislav, yeah?
We will multiply the first row by -3 and the third one by 2.
Are you
No.
sure that we multiply the first row by -3?
By -2.
Yeah, by -2 because we have
One
2 here.
will leave it.
So what?
It will be 4 plus 3. It will be 7.
By the way, we multiply by -2. Don't lose minus.
It will be -4 plus 3. It will be -1.
Yeah, attentive.
And it will be 2 minus 1, 1.
Yeah. Okay, and with the fourth row, who want to be a volunteer? Daniil, yeah?
We can multiply first row by 6 and add it to fourth row.
Didn't
By
you
-6.
miss anything? -6, yeah.
Yes, by -6.
Yeah, be attentive with the signs. So, and what coefficient we have here?
-9.
-9, yeah.
7.
Yeah. Okay. And the next we need to construct, we need to calculate our determinant just in a simple way, and which elements we need for now. Who will go the next? Yeah, Daria?
So we take the third column and we write the element, which is 1. Then we multiply it by -1 in power of 3 plus 1, which is 4.
Yeah, so actually we need only these elements. And how it will look like. So let's write it in details. We all know that multiplying by 1, it actually nothing changes, but let's write in detail. Let's write in detail. So 1 plus 3, actually it's 1. And here we have such determinant. Okay, and here we can either solve it like in triangular. Okay, let's just solve it by using a triangular rule. So -4. Okay, let's okay, let's go with the black color. -4, and here, where is the brush? -4 minus 9 by 3 by 3 -81 and plus 1 minus 9, because two minuses, and we also subtracted. So attentively with the signs, plus, so, okay, 12 by 7, 84, and plus 3. Actually,
I think it's not +1, but +7 maybe.
Sorry. Yeah. That's just my handwriting was not clear for me. Yeah. Thanks for your attention. Actually, you are helping me as well, and it's good that you follow. It's very nice. So, how to simplify it?
It will be 0.
Yeah, actually 3. Just a moment. 10. Yeah, actually it's 0. Yeah. So 0 determinant. And we have some time. We will try to reduce determinant to triangular form. Maybe you have questions for now.
No questions.
Okay, let's open a new file and and calculate one more determinant as we have enough time for that. And we will transform it to triangular way, to triangular form. Actually, it's a good example. So this determinant is a good example for triangle. Actually, we are going with the same way as it was before. So so currently we are setting zeros in this column. Okay, let's go with black for now. The first row is not modified. Yeah, we have zeros. And actually identically as we had. But we need to do more transforms. So here, help me, which numbers, which coefficient we have in the second row. Actually, who will be a volunteer? Mykola, yeah?
Okay, we 2 multiply by -1. Then we have -2, 2, -2 in the second row.
Well, actually, what we do? So we just need
First
to.
row.
Yeah. So we just in this case we just subtract the second first row from the second row. So maybe I heard you incorrectly. So which coefficient here?
-1.
Why?
Because 2 minus 2 is 0.
2. And here?
2
2.
and -2.
Yeah. Okay. Who will be the next? Actually, let's ask anyone who I haven't heard during the lesson. Okay, maybe, yeah. By the way, you're so active people, but here we have some of you that haven't asked yet. Okay, Volodymyr, are you here? So can you help me with the coefficients, which will be in the third row? Don't be shy. Okay, maybe anyone else. Okay, who will have the priority? Actually, people that haven't answered. Oh, yeah, Maxim, if I'm not mistaken, problems with Zoom. Okay, if I'm not mistaken, Maxim is a new person. So, yeah, help us.
So we can take the first row and multiply it by -3 to eliminate 6 in the third row. Yes.
Yeah.
Then it would be -6. -6 plus 6 equals 0.
Mm-hmm.
Then 3 multiplied by -3, -9, 2 plus -9 equals -7.
Mm-hmm.
-3 multiplied, that would be 9, and then 10. Yes.
Yeah.
And the last one would be 0.
Why?
No, -12. Yes.
Are you sure? Oh, yeah, -12, my bad. Yeah, I just was looking at 6, but forgot that here we have 2. So, yeah, you are right. Okay, and who will be the next? Oh, Sophia, yeah.
I'll try because I may do some mistakes when I do
Don't be
this.
afraid of making mistakes.
I think we should multiply by -1.
Yeah. And
wait a second. We in the second row we take row or column?
we are taking a row.
Under
So let me just so this so this row, so maybe would be helpful.
In the second column we have 0.
Yeah, 0.
In the third column we have 3.
Yeah.
And in the third column, or fourth column, we have 1.
By the way,
-1.
no,
I made a
great.
mistake in my notes. Sorry. -9.
Yeah, -9. Don't forget signs. Okay. So how much time we have? So actually we can have more iterations. And what are we going to do now? Okay, so any questions, right?
No questions.
Some question? No, but I see that Mykola and Daria raised hands, or you are just going to comment in.
Just want to answer, Ned.
Ah, okay. Yeah, actually, that's nice. So, and let's answer. Okay, and currently, yeah, so not actually beautiful numbers we can see, but the idea is, okay, let's do one more iteration, and then we maybe will finish. But anyway, let's continue. So we need this row. Actually, yeah, maybe what do you want to suggest? What we are doing now? What changes? I see your hands. Okay, so Daria, you are the first in the queue. So your turn.
I think we should multiply the second row by minus 3.5 and then add this number to the third row.
Yeah. Actually, we just reduce it. So we need to set zeros under this 2. Let me just mark it here. Yeah, so here we just set zeros. So here nothing changes, and here we write zeros. So okay, I know that everyone can multiply and add, so just let me do it in my own already. So here we multiply by 3.5. So and add. So here we have 17, and here 19. Here actually nothing changes. Okay. Actually, here we have not such good numbers. So a lot of fractions. Oh, -9. Why didn't anyone tell me that I lost minus?
Sorry, how we delete -7? Yeah, confused.
Yeah, actually, we multiplied. So we just were doing like with the first row. So we multiplied it by minus 3.5 and added to this row. So 2 multiplied by minus 3.5 is 7. So here we get 0. Yeah, my bad. Sorry. Yeah, my bad, actually, science. So let me correct. my
You can
calculations.
just press Shift and use your left mouse button to change the size of your brush.
Thanks. Okay, but now I just need to turn off the eraser. Yeah, here we have -7 and we add it to 10, so we have 3. And here 7 plus -12, and we have -5. So really good example. And what we do here, we just subtract this row from this, and we have 0 here, and here -4. And actually, how do you think will the final result look like? So the simple way to calculate our determinant. Daria, yeah?
If I remember well, just multiply all the elements of the main diagonal.
Yeah, sure. Just all elements we multiply. Actually, if we, for example, we multiply 2 by algebraic complement, so we will, in this determinant, we will have only the main diagonal and no scenes to use a triangular rule. So we just multiply only main diagonal. Yeah. And it looks really easy. So actually what we have 16 multiplied by 3 and it's 48. So it's done. Any questions maybe?
No questions.
Okay. So currently our lesson is finishing, and I will share a recording of the lesson with you, so we'll have the ability to revise it, and also start doing the first individual exercise if you have access to it. And actually, for more practice, do some exercises that left for the homework. It will be helpful for you during the test or for exercise, for individual exercise. So, yeah. And I wish you peace. So bye and have a nice evening.
Thank you very much for your lesson. It was very clear explanation, I think.
Thank you for your feedback.
Bye.
It's important for me. Bye.
Bye.